This is a talk that I originally did at the Sanog conference in Bangladesh, so it's a bit more applicable to that sort of region than to the well-populated areas of North America that most of you are used to working in. So it's here largely as an indication of what's going on in other parts of the world, and hopefully a bit as something to think about when deploying infrastructure that's trying to serve users in other places. So if we look at the way the internet is currently constructed, there's this very well-connected core, which is the major metropolitan areas of okay. Which is the major metropolitan areas of North America, Western Europe, East Asia, and a few other places. And within that area, there's really good connectivity. There's lots of fiber, lots of redundancy, lots of cheap bandwidth, and you can pretty much take for granted the ability to send large amounts of data really quickly between urban areas of the developed world. But in the rest of the world, you've generally got lots of ISPs in a region which each have connectivity to that core, but it's separate connectivity and they often don't connect to each other. And connections to that core can go a very long way. There are often satellite links to other continents. And since they don't connect to each other, even the local connectivity uses those connections. So if you're wanting to, say, make a voice over IP call to your neighbor, chances are you're going to go halfway around the world and back to do that. So the internet often doesn't work very well in those places. So here we've got a trace route that I've been calling the Packet World Tour. This goes from Kathmandu in Nepal to a place that I think was about 20 miles outside of there, by way of Los Angeles, which is, I believe, 11 time zones away from there. Back to so Nepal, satellite to Honolulu, fiber to Los Angeles, fiber to Singapore, back up to the satellite, and back down to Nepal. And so in that case, we've done basically the equivalent of a circuit around the world to go 20 miles, and we've spent 1.7 seconds doing so.
Use IPv6. Fewer hops.
This is the example that I think a lot of you are more familiar with. And this IP address I traced to is just a random IP address that didn't appear to be firewalled off in a way that blocked the trace route, but it's a trace route that goes across the Nepal Internet Exchange in Kathmandu and takes 24 milliseconds to go a not much shorter distance. So this is a way in which the internet differs significantly from traditional phone networks. On traditional phone networks, there's a huge cost advantage to making local phone calls, and definitions of local have shifted a lot over the last several years. At this point, from my cell phone, the local calling area is the entire U.S., but there's still a big difference in cost between calling the U.S. and calling various other parts of the world from it. And local phone calls tend to be pretty reliable because the connectivity is good. Well, international phone calls are a different story. If you're calling some poorly connected part of the world, often you end up giving up and trying to call again the next day. But most people don't notice when the international phone networks break. Because if most of the phone calls you're making are local, an outage of your international phone calls won't be all that noticeable. With the internet, at least if you believe what you read in the press about it, distance is dead. Local and long-distance communications cost the same. You can talk to anybody anywhere in the world as easily as if you're talking to somebody local. And this gets talked about as a feature, and sometimes it is. It's pretty cool to be able to talk to people far away for free or close to free, or at least it seems free from this end. But what in fact happens with this is that the reason that distance seems somewhat insignificant is not that everything looks like it's local. It's that in a lot of places everything looks like it's long distance, and this reduces local communications to the flakiness level that we expect from the international connectivity. So this manifests itself in a couple of ways, both in terms of cost and reliability. So if you look at bandwidth costs in the urban U.S., and I'm using Bill Norton's figures from last fall here, so this has probably come down a bit, but with a 1 megabit commit rate, cost in the urban U.S. has tended to be around $100 a megabit per megabit per second per month recently. If we go 500 miles east of here into northwest Montana, where everything gets backhauled to Seattle over microwave links that have to go over mountains that don't have power at the top, we end up with that cost jumping to around $1,000 a meg. And then we go to Kathmandu, where that trace route was from, and we get $5,000 a meg because stuff is going over satellite. But there's enough population density and so forth that peering locally was worth doing. And local traffic they can do at $50 a meg. And that's not just a developed country issue. It's also, well-developed areas that just are far away from everywhere else have this problem also. So Perth in Western Australia, where when I was there a few months ago, people kept telling me that they were the most isolated big city in the world. If they buy global internet transit, they pay $500 per megabit per second for it. But if they peer locally, their cost of connectivity is there's less than $10 per megabit per second, because they've got to set up very much like Seattle, where they've got a big downtown skyscraper where most of the ISPs are, and the exchange point is in the basement. And the ISPs in Perth and in Nepal and in a bunch of other places are starting to notice that this is an issue, and charging their and doing traffic measurement and charging their customers occasionally. So I believe both in Perth and in Kathmandu, you've got a lot of ISPs that are offering free or flat rate local connectivity, and then charging per bit for stuff that goes over their international links. And in New Zealand, there seem to be two products, global transit and domestic transit, which are priced very differently. And this also, perhaps even more significantly, makes big reliability differences. So I'm not sure how many people in here remember the fiber cut in Sri Lanka last summer or last fall that got a fair amount of discussion on the NANOG list. There was a ship that was dragging anchor in the Colombo harbor and cut the only fiber cable going into the country. And I haven't been able to find a whole lot of accounts from people in Sri Lanka of what internet connectivity looked like at that point. The press reports I could find reported it as an outage of internet and international phone service, which makes the internet look pretty fragile if local phone service continued to work, but the internet just fell over. So what really happened there, and again, this is pure speculation on my part, but this is what I think is a fairly realistic scenario, and if anybody knows more about this, please let me know. There is a local exchange point there, and I think the ISPs there are reasonably well peered. So layer 3 connectivity between the ISPs should have continued to work, but there's no root DNS server there, which means that DNS lookups, at least if anybody reloaded a name server and flushed the cache, which servers reboot a lot in places where power isn't reliable, would have meant that anybody trying to access anything by domain name wouldn't have worked. And even with DNS, if you think of the internet as your access to content that's hosted in other places, that's still a problem. So this is an issue that's certainly not isolated to Sri Lanka. That just made a good example. So anywhere with fragile external connectivity has these problems, and in regions with satellite connectivity, these problems are treated as somewhat normal. At PCH, we've got a lot of our Anycast DNS nodes in places that are satellite connected, and our management connectivity for them often goes down for hours or even sometimes days at a time. So I think there's a a somewhat different way that we need to think about internet engineering in order to accommodate regions where long-distance connectivity is hard to do. So that the current core works well for the parts of the world that it covers, but the rest of the world really shouldn't have to send everything through it. So if we instead think of this as lots of regional cores where you've got your local infrastructure, all the local stuff you need to talk to, and then long-distance circuits that you use for when you need to talk to people far away or talk to servers far away, then that makes a lot more sense and would allow these areas to be a lot more self-sufficient. And if the internet is going to replace the traditional phone network for voice over IP stuff, we can't have it being flaky we can't have it being a lot more flaky than the phone network is. So how do we get there? The first step is obviously to keep local traffic local, which can either be done with an exchange point or a monopoly transit provider. With an exchange point, all the ISPs should have access to local peering, and this doesn't mean that everybody needs to peer with everybody else, because if you buy transit from somebody who peers locally, then that's essentially paying someone else to do your peering for you. And this scales pretty well, because it doesn't really put a hard limit on the number of participants in a market. You can also do this with a monopoly transit provider, which has the same effect of keeping local traffic local until somebody decides to compete with it, and then you're back to where you started. And monopolies tend not to have much incentive to improve service or lower costs, so that doesn't work nearly as well. But exchange points really aren't enough here, because keeping your local traffic local doesn't help if what you need to talk to isn't local. And if everything you need to talk to is dependent on DNS, then nothing's going to work if your DNS isn't local. Even with local DNS, I go to a lot of places with pretty poor connectivity and start looking over people's shoulders, and what are they doing? They're emailing their other local friends with Hotmail, which means that the guy they're emailing may be pretty close to them. They may have decent connectivity were they to send raw packets to each other, but they're dependent on mail servers on other continents to send their local email. So to really be self-sufficient, a region needs not only local connectivity, but also its own critical services. And that leads us to, what is a critical service, which is an awfully subjective question to answer. DNS obviously is. Root DNS we talk about a lot, and there's a lot of work going on anycasting root DNS servers. What I hear talked about a lot less is figuring out what top level and second level and so forth domains to put stuff in. If you've got, most places have local, or at least most places with decent local connectivity have local servers for their country code TLDs. So if you can figure out what the IP addresses of your ccTLD servers are, you can generally do lookups of domains in the local ccTLDs. But there are also often a lot of other zones in local use. A lot of sites get addressed out of .com or .net or various other GTLDs, and in those cases, those servers or the DNS servers for those TLDs are often far away. So you may have your local server being up, but you can't do a lookup of domains in the GTLD that it's in, so it's effectively down. So use of domains without local DNS, or without DNS that you're robustly connected to, should probably be avoided. And email, your local ISP's email server is probably local. Yahoo and Hotmail, I think, probably aren't in most poorly connected places. So it would be really nice if either the big operators of free email services would look at spreading their infrastructure out a little more, do different servers for different regions, or if local companies would see that as an opportunity and start doing their own local free web email services, which I think may happen in some places, in which case they could sell local advertising and hopefully make some money that way. VoIP services, as we move from PSTN to to VoIP phones. There are a number of things that need to happen for a VoIP phone call to be established beyond just the two phones being able to see each other. You need to figure out how to talk to each other, which involves being able to connect to the SIP server if you're using SIP. If you're using enum for phone number lookups, then you need at least the local part of the enum tree, I guess the roots of that plus everything for your local country code. Okay, and VoIP to PSTN gateways if you're using this for local calls to the PSTN. And then there's the question of what else is a critical service? Is Google a critical service? Google employees tend to emphatically say no. A lot of other people seem to answer yes to that. I don't know how, that's probably not all that easily replicable. And what about Windows Update? What about various other content providers? This is really something that content providers should be thinking about when deploying their servers. Who's the target audience who should be accessing this content? So what's being done on this so far? Exchange points are already being built in lots of places. Local TLD operators are hosting their own, are hosting their servers in their own regions in a lot of cases, which doesn't also preclude having servers outside the region. And this helps a lot if there is a local exchange point, but without one that doesn't do much because you just have connectivity going out of the region and then back in, which is really slow. Root servers are becoming more distributed, and content providers who are catering to local audiences are starting to host content locally in some places. But a lot more needs to be done on this. There are a lot of regions that still don't have exchange points, without which none of the rest of this matters much. When I last checked a couple months ago, it looked like the only developing countries with their own root servers were, or the only cities in developing countries with their own root servers were Johannesburg and Jakarta. And this isn't really so much of a problem with the way the root server operators are planning things, it's just that the areas that are able to fund lots of root server deployments tend not to be the areas that need them the most. And a lot of the GTLD footprints are still pretty small. And also, ISPs in these areas need to help their users think about this to some degree and figure out, do I really want a domain and some GTLD for my local website? That happens to a fair amount because it's fairly easy for somebody to understand that the local service is faster than the faraway service. But there are also services for which location doesn't noticeably affect performance. I think the instant messenger clients are a pretty good example of that, where that can surprise people when they stop working. And then just a couple caveats. This shouldn't be seen as an attack on long-distance communication, because that the internet makes long-distance communications much easier is a very good thing. And so I'm just trying to say that it shouldn't have to be depended on for local stuff. Thanks.
Before we take questions, whoever is presenting next, can you come on up? And we're going to be really short because we're going to compress into my break time. And
this isn't even a question. This is a comment. Matt Petak from Yahoo here, since we were named up there. What we have found, and this is a comment to the whole community here, is we are deploying content in other countries. We are building data centers in other countries. We are finding network operators that will peer with us here in the United States, even though they are in that remote country, and we have a data center in that remote country, but they will not peer with us in that remote country. So content goes from remote country to Palo Alto, California, across the circuit we have, back across the circuit they have to the country where they were 6 kilometers away from us. This is a problem, people, not from the content provider side necessarily, but from the network operators who decide that for some reason it's better to peer in California than in their own country. If we can solve that, I think we can make Steve a lot happier.
I think that's an issue that depends a lot on which remote countries you're going to. If you're somewhere where the local ISPs have good fiber connectivity to the U.S., it's very tempting for them to do that because they can keep encroachers out of their local market. I think once they get into the point where they're paying thousands of dollars a megabit for their satellite connectivity, they're a lot more eager for that sort of thing.
But the point is the content providers are going to the countries, and it's not helping your case.
Okay.
Kevin Oberman from ESNet. Just a quick comment for whoever's handling the web pages. The link from the abstract page off the agenda for this talk is actually pointing to the previous talk. It's just a minor typo.
It's fixed.
Oh, it was 5 minutes ago. Sorry.
Refresh your cache.
Andrew Dahl from Boeing. The question that I kind of have about your whole talk is I agree that making infrastructure more sound in catastrophe situations is certainly a good thing. But in my mind, it comes down to one of two things: economics or regulation. And in general, we don't see economics, at least I don't see economics, pushing people to move a lot of these services into these far-reaching areas. So then you ask questions about regulation, and I don't know if you see regulations changing such that would encourage or cause local ISPs to actually perform these services locally.
Well, I think that as far as big content hosters in other places are concerned, if Nepal or Bangladesh or something says Yahoo must install a local server here, I don't think that's going to have any effect. As far as getting the ISPs to connect to each other locally, I think that's being I think that's being talked about in some places, and regulation is always scary on the internet because the regulators often don't know much about it. And
but regulators could, not knowing much about it, write rules like you cannot connect to Yahoo in San Jose. You must connect to Yahoo locally, right? And what are the ramifications of that? How do you enforce that? But
I think I'm going to let Bill answer that one.
We really have to wrap this up because we've got 45 more slides and we've got 10 minutes. So, Bill.
There we go. Really quickly to Andrew's question. Regulation that names Yahoo is probably really bad regulation. On the other hand, the policy that we have been talking with regulators about in countries where they really want to regulate this kind of thing is to say that if you are a licensed telecommunications service provider, you must have a mechanism for delivering domestic traffic without it crossing the border, right? That's a very generic regulation. It's not technology specific, and it doesn't say that you have to peer. You could go and buy transit from somebody who peers and you'd be completely okay. So that's the level of generic kind of regulation that's relatively safe.
Thank you, Bill. Once again, thanks, Steve, for intriguing topic.